For example, we have infinity, and infinity type of discontinuity. When we have both sides, well, both of them will never touch the y-axis, and therefore, also in here, there's no limit.
All discontinuity is a discontinuity that is like this, that have a space here, is breakdown, but you can fill it with another point, another function here. That's why you have the renewable discontinuity. The endpoint discontinuity is the one that ends in the point of origin here and does not have a limit because come from the infinite to the end to the origin point.
Hello there. Well, right now I'm gonna explain to you discontinuity that is the type of removable discontinuity, right? So, with the removable discontinuity, we have a function, normal function with usually a hole, and then we have a point right here, a black point which represents a number or a digit or something on the graph that is like a point in x, right? So with this two, we can actually find out, depending on what it's asking you for, uh, what x and what the limit is and what that point is. So if it's asking us for the point of y when x equals 2, that would be minus 2. Because it's asking us for the whole point of the function, right? And it's right here. It's a whole point, it's a whole digit. But if it's asking us for a limit, which is limit of, let's say, 2 on both sides, it could be both sides, it would be 1 point, let's say 1.63. That would be the limit of y, because we could estimate that the limit would touch there. This hole, we could estimate that we could fill it up actually by estimating that it would actually touch right there. And if it's asking us for a whole number, well, we have the whole number right here. Real quick, well, for example, when we have a jump discontinuity, well, jump is that they are not, they don't have a pattern, the function themselves. So, for example, let's say that this one has its own function, is right here, this one right here. So, if it's asking us for the limit of 1, for the limit of 1 on both sides, it could never be because they're not touching and you cannot predict a pattern right here. But if it's asking us for the limit of 1 plus from going to this side, it would be 2 because it comes from this side and ends in 2. And if it's asking us for a limit in 1 minus, it's coming from here and ending here, so it would be 1.
And it's normal pattern because of this. This is called a hole. A hole can be expressed like this. So this is a hole. Also can be explained as a limit.
One of the examples of discontinuity, the first one is jump. It's when we have a graph and we have both functions that are not connected and they don't follow any pattern, and therefore there's no limit.